This is R.D. Sharma Solution Class 12 Chapter 19. Exercise is 19.24. Indefinite integrals we are talking about. Now the questions we have already done, this type of question, and we have to convert or we have to represent the numerator in the form of a denominator or the differentiation of the denominator. That means 5 cos plus 6 will equate it to actually the denominator and the first denominator and then the differentiation of the denominator. And since we have the maximum number of items or the terms are 3, so we will include 3 terms. So first is a constant, and now you can write the denominator. Then we have b. Now you can write the differentiation of the denominator. What is the differentiation? 2 cos is minus 2 sin x is cos x, and 3 goes away. It's negative 2 sin x plus cos x. Then we add a constant. See, even if you are adding a, b or c and it doesn't count, because after equating you will get some of the elements or some of the constants you have introduced as 0. So don't worry about that. You can include any number of constant. So now multiply inside 2a cos x plus a sin x plus 3a. Now multiplying b inside, negative 2b sin x plus b cos x plus constant of integration. Now let's equate. This is the cos x term, this is the cos x terms. So take cos x common, you will get 2a plus b, and this will be along with cos x. Now let's take the sin x terms. Now this equation is very important because this is the numerator and we are going to put a, b and c after finding it in this numerator and then keep the denominator as it is, and then we try to integrate. So now we have a minus 2b into sin x, then we have 3a plus c, and this 5 cos x plus 6 has to be equated. Now what is equivalent to cos x? What is the equivalent term? 2a plus b. This equals to 5. This is the first equation. The second term is sin x, and we don't have anything on as sign on the left. So we have a minus 2b equals to 0. Then we have 3a plus c, and since it is a constant and we have a constant 6 on the left, so we can equate 3a plus c equals to 6. So we need to solve this. Try to find out a, b, c. There will be certain questions where I will give the task to you. Let me solve it here. A equals to 2b, I am placing a equals to 2b here, and we get b equals to 1. Now just write this b or put this value in a, you will get 2 into 1, which is 2. Now let's put a here, 3 into 2, 6 plus c equals to 6. So c equals to 0. So as I told you, even if you add certain constant, they will get 0. So don't worry about how many number of constants we want. Now this integration will become like this. 2a into 2 cos x plus sin x plus 3. What is a? 2. And then you will put this. I am writing the numerator just now. So 2 cos x plus sin x plus 3. And in the denominator you have to take the denominator and place it as it is, because we haven't done anything with the denominator. 2 cos x plus sin x plus 3. We have used the denominator in order to form the numerator, but we haven't done anything with the denominator. Now the second term will be along with b. And b is since 1, so we don't worry about that. We just write the negative 2 sin x plus cos x, and denominator will be the same, 2 cos x plus sin x plus 3. So let's write it 2 cos x plus sin x plus 3 here. And then we have a constant, and since we have a constant c equals to 0, we don't worry about it. We don't write it at all. So how easier it has become. You can just cancel these two terms because they are exactly similar. We have a dx. So 2 into integration of dx will be x. How about this? If you take t as the denominator, the numerator will come as the differentiation. So if you take t equals to 2 cos x plus sin x plus 3, dt will come as like this, minus 2 sin x plus cos x, because we have already differentiated it. So this is dt in the numerator, t in the denominator. That will form log modulus t plus c. This is the second term I am talking about. First term we have already got as 2x. Second term will be log modulus of t plus constant of integration. So we'll just write log, and in place of t, because we have taken t as the denominator, if you remember. So we have log modulus. You can also write ln because log base e it is. Now write the denominator which was taken as t, 2 cos x plus sin x plus 3 plus constant of integration. This is your final answer. Now how to do this? The solution or the reference is in front of you. The whole idea is to convert the numerator in the form of denominator or the differentiation of the denominator. Other things remains the same. Okay, there is a question we are doing just now, which you see on the left. But one of the question which you see on the right, that is going to be after this question. So both the questions are similar. So if you want to do the second question after completing this question, then you need to understand this question very well. So let's do this question. Now we have to represent the numerator in the form of the denominator. So we have 2 sin x plus 3 cos x, and this is equal to, just place the constants now, a into, what is the denominator, 3 sin x plus 4 cos x, this is the first term. Then we have b, capital B, constant we are introducing, and we have to differentiate it. Sin x will be cos x, 3 cos x, and it will be negative 4 sin x. So write it here, 3 cos x minus 4 sin x. If you want to add, you can add a constant also if it is not required, or it will be eliminated by itself. So don't worry about that. So I'm not adding a c. You can add c and you will get a 0. I have already done it, so I know what to put actually. So now multiply this internally. 3a sin x plus 4a cos x plus 3b cos x minus 4b sin x. Now sin x and cos x, you can just collect these terms. So it will be 3a minus 4b. 3a minus 4b or 3a negative 4b sin x. How about cos x? 4a plus 3b cos x. It's 4a, so I'll just write it. Now equate it. 3a minus 4b is equal to 2, and with cos x, 4a plus 3b. Please remember, it's 4a. I'm just changing it now. So 4a plus 3b is equal to what? Now equate it to the left. It will be equal to 3. So we have two equations now. 4a plus 3b equals to 3. This is the second equation. Now we can find out the value of a and b. Just multiply the cross multiplication method. Multiply first by 3, second by 4. So this will be 9a minus 12b equals to 6. This will be 16a minus 12 plus 12b equals to 12. Now add these two. 9a plus 16a is 25a, and 6 plus 12 is 18. So a will be equal to 18 by 25. I hope you will be able to solve for b. Just put this a in any of the equation. You will get b equals to 1 by 25. Now let's make the integral. We already got this equation number 1, which is actually the numerator. So let's just write the numerator in this form and then divide the denominator as usual. First is a is 18 by 25. I always take this constant outside the integral because it won't affect. 3 sin x plus 4 cos x will remain like that. And what is the denominator? It's same, 3 sin x plus 4 cos x. So let me write it as 3 sin x plus 4 cos x. How about the second term? B is what? It's 1 by 25. If you remember, I told you that B would come as 25, 1 by 25. Denominator will remain the same, 3 sin x plus 4 cos x. As I told you, we haven't done anything with the denominator. We have just converted the numerator in the form of the denominator. So 3 cos x minus 4 sin x. Now if you have a dx here, you see the first term, it gets cancelled. 18 by 25 and integration of dx will be simply x. So 18 by 25 x this will be. This is x. Then we have 1 by 25. And now you see here, if you take t as the denominator, the numerator will automatically come. That is, if you take t equals to 3 sin x plus 4 cos x, and if you differentiate it, we have already done this and kept it with b initially in the equation number 1. So dt will be equal to 3 cos x minus 4 sin x dx. So this numerator has come dt when we kept t equals to the denominator. So it's simply log modulus t plus constant of integration. So you can just write it like this. It's 3 sin x plus 4 cos x in log. So let me add a log also. Log modulus plus constant of integration. That's your final answer. So this is the result we were talking about. This question actually we have done already, and next question is also of the same approach, same thing we have to do. So as I indicated you earlier in the previous question, that this question will be exactly same as the previous one. So I'm presenting you the reference and you can try it yourself. If you have any problem, just comment. Now this question, 1 by 3 plus 4 cot x and 1 by 4 plus 3 tan x. Now it can be 3 cot x plus 4, it can be 4 tan x plus 3, all combination and permutation can be made. But the main idea of actually showing you this question, the other question, is that the approach remains the same. So I'm just trying to tell you that the next question will be exactly done like this. So just concentrate on this question. What we'll do is we'll convert this cot x into cos x by sin x. Wherever it is tan x, you just convert it into sin x by cos x. That is the approach. Now take the LCM of the denominator, 3 sin x plus 4 cos x. This sin x goes up, which is in the denominator actually. Denominator of the denominator, it goes up. So this will go up and we'll get sin x divided by 3 sin x plus 4 cos x. So 3 sin x plus 4 cos x is in the denominator. Now you already know how to do this. The previous questions, I have already showed you that sin x has to be represented in the form of the denominator. First the denominator, then the differentiation of the denominator. So sin x can be equal to a of the denominator plus b into the differentiation of the denominator. What is the differentiation? It's 3 cos x minus 4 sin x. Now if you want to add a constant, you can add a constant. Ultimately it is going to come as 0. But still multiply inside 3a sin x plus 4a cos x plus 3b cos x minus 4b sin x. Now you can take these 3a sin x and minus 4b sin x common from this. So 3a minus 4b sin x it will come. Now cos x you can take common, 4a plus 3b into cos x. And this has to be equated to sin x here. So this has 1 in front of it. So you can equate 3a minus 4b is equal to 1, which is the coefficient of sin x. And there is no cos x terms on the left. It's 0 into cos x actually. So you can equate this 4a plus 3b equals to 0. Now you can just easily solve it. You know already how to do this. This is simple algebra. A and b can be found. So let me write the a and b values here. A will be equal to 3 by 25 and b is going to come as negative 4 by 25. Now just use the equation number 1 and write this equation number 1 and then take the denominator as 3 sin x plus 4 cos x. Don't take 3 plus 4 cot x already then, because we have already converted it into a more known form which can be differentiated easily. So a is 3 by 25. I have taken it outside the integral. 3 sin x plus 4 cos x remain inside, and denominator is 3 sin x plus 4 cos x because we have converted it. So 3 sin x plus 4 cos x here. Then we have minus 4 by 25. Negative 4 by 25 I have taken outside integration. And 3 cos x minus 4 sin x. So let's write it, 3 cos x minus 4 sin x divided by, same thing, denominator remains the same, 3 sin x plus 4 cos x. Now you call it as I1 and this can be called as I2. The first term is quite easy, 3 by 25, this gets cancelled. So you have a integration of dx which will give result as x only. So 3 by 25x is the first term, minus 4 by 25, this is your second term. Take the denominator as t. And you already have done in the equation number 1, I told you that we have already differentiated it. 3 cos x minus 4 sin x will come. So this dt will come as 3 cos x minus 4 sin x into dx. It's basically dt by t, integration of this. This will be log of modulus of t plus constant of integration. So you have a log and modulus of t. So modulus of 3 sin x plus 4 cos x and this plus constant of integration. That's your final result. This is your final result. So this is the reference of this question, 1 by 3 plus 4 cot x. And main thing is to convert cot x into cos by sin. And this question, which I was talking about earlier, has the same way of doing it. Here you just have to convert tan x into sin x by cos x. And the reference is in front of you, just if you want to do it by yourself. Otherwise, just let me know and we will deliberate upon this. Okay, the next question is like this, 2 tan x plus 3 divided by 3 tan x plus 4. And the next question which is coming up is 8 cot x plus 1 divided by 3 cot x plus 2. You can always convert these two in either way. If you take 8 by tan x, it will be 8 plus tan x divided by 3 plus 2 tan x. So the same thing will come. Here tan x has to be converted into sin x by cos x, and here on the right cot x has to be replaced by cos x by sin x. So the exact same scenario will be there for you to solve, and I'm quite confident that you know by now how to solve it. So I'm writing tan x as sin x by cos x. In short, 3 sin x by cos x plus 4. Take the LCM, it will be 2 sin x plus 3 cos x divided by cos x. And this will be 3 sin x plus 4 cos x. So 3 sin x plus 4 cos x divided by cos x. So the denominator gets cancelled and you have a 2 sin x plus 3 cos x divided by 3 sin x plus 4 cos x. Now you see this has already been done. 2 questions I showed you. Same thing we have done already. That's why every question comes down to the same path, same way we have to do it. So we have to represent the numerator in the form of the denominator and the differentiation of the denominator. That means 2 sin x plus 3 cos x, which is the numerator, has to be equated to a into the original denominator, which is the 3 sin x plus 4 cos x. So let me write it 3 sin x plus 4 cos x here. Then we have the b into this 3 sin x plus cos x differentiated. It will be 3 cos x minus 4 sin x. So this question was already done previously, if you remember. But still, for the sake of completion, I'm doing it so that you may recall, or these things get feeded into your mind and kept into your permanent memory. So b into 3 cos x minus 4 sin x. Now multiply this inside. You'll get 3a. Let's combine this together. So 3a minus 4b, this comes with the sin x terms. And I'm multiplying and collecting in one simultaneous step. So it will be 4a minus plus 3b, and it will be with cos x. Now just equate. Sin x coefficient 2 and 3a minus 4b can be equated. So 3a minus 4b equals to 2. And 4a plus 3b, this will be equated to 3. Is equal to 3. So you can just solve it. I hope these 2 questions can be solved. A will come as 18 by 25 and B will come as 1 by 25. Now equation number 1 has to be written, and you can use this equation actually, because 2 tan x plus 3 divided by 3 tan x plus 4 has already been converted into sine and cos form. That we have to utilize. So A is 18 by 25. I'm taking it outside. What is inside? 3 sin x plus 4 cos x, which is the original term, which is the original denominator actually. And it has the denominator same, so just write the same term, 3 sin x plus 4 cos x here. What is the next term? What is b? I told you it will come as 1 by 25. So just write 1 by 25, integration of, and the differentiation of the denominator, 3 cos x minus 4 sin x divided by, this all have dx along, and 3 sin x plus 4 cos x in the denominator, 3 sin x plus 4 cos x. What do you get here? This is I1, this is I2. So 18 by 25 here, this gets cancelled. Integration of dx, which is integration of dx is simply x, so you can just write x plus 1 by 25. Now this I2, take this as t. So t will be equal to 3 sin x plus 4 cos x, and the differentiation has already been done in the equation number 1. So I'm directly writing dt will be equal to 3 cos x minus 4 sin x into dx. So eventually it's simply dt by t only. And dt by t will give you log modulus of t plus constant of integration. Log modulus of t. T is what? Which is the denominator. So we can just directly write this in the actual solution. So let me write it here. Log modulus of, just take the denominator, 3 sin x plus 4 cos x plus constant of integration. That's your final answer. So how it is going to be done, because you have to write all these in the prescribed format which I presented. Your answer should be almost similar to this answer. This question, as I told you, has the same scenario, same process as the previous one. So let me show you the reference and you can follow this question. Try to do it. Otherwise, just let me know. So this is the end of this exercise. I hope you understood things very well. Thank you so much.